So it's the last session, last talk before lunch. So this software is supporting the JavaScript language specification, and he's the first speaker of this workshop coming from a language community, not from academia. So I hope it captures your interest, and let's give him a big hand.
Thank you. Yeah, I'm Michael. I work at F5, and I'm one of the editors of the JavaScript specification. And Jiak did a really good job of priming you for this, so my first few slides might actually not be necessary. So JavaScript, yeah, it was originally designed for use on the web at Netscape, but now it's available on a huge variety of platforms. It's still obviously used in modern web browsers, but it's also used in standalone runtimes, which are hugely popular, and also embedded in HTTP servers. It's used in operating system shells, microcontrollers, all sorts of places. So because of that hugely diverse set of stakeholders that JavaScript has, JavaScript is now developed within ECMA. It's an international standards body. It's composed of experts, practitioners, implementers from all over, from industry, from academia, government, research institutions, and they all send representatives from all over the world to work on JavaScript. As you know now, the spec is called ECMA 262. ECMA just publishes a bunch of numbered specs, and we got the number 262. And it's authored using English prose. So it's partitioned into these abstract operations, which are a function-like specification mechanism. We try to use highly regular phrasing, making it effectively a pseudo-programming language. On the rigor spectrum, it's somewhere in the middle, probably for this audience, not very high, but we think it's the appropriate trade-off for our readers. So we have to consider that we have a lot of different kinds of readers. We have implementers, of course, but we also have the JavaScript programmers themselves, both like really novice ones and veteran programmers. We have educators in the community, people who write documentation, academics, of course, as well, and tooling that consumes the spec, as we saw with ES Meta. So we think this is the appropriate kind of abstraction to use. It's shown over the years to be sufficient. Between the specification and the official conformance test, there's very rarely a new feature that results in an engine divergence. So that's all we need. That's the bar we're trying to meet. So in the old days, we used to do this. We had a single editor that used Microsoft Word and this track changes feature, and would periodically send out updates to review, and all spec work would go through that one person. This is really not sustainable. We did manage to release 6 specification documents using that process, but because of the ever-increasing size of the specification, as you can see there on the page numbers, the scope of the language, and the rate of additions that we wanted to make to the language, this is just this couldn't remain this way. There is a really good paper by Alan Worth-Brock and Brendan Eich that was presented at HOPL4. I recommend reading it if you want to know more about the history. But moving forward, since 2015, we have a new process that is more decentralized and allows us to scale. I don't think that's rendering very well. But anyway, so with this new process, we also now have editor groups. So there's more than one person working as editor. And I've been part of that editor group since 2020. The biggest other change in our process, though, is that proposals are now shepherded through this 6-stage, these 6 stages of proposal. Yes, I see that some of you are noticing there's 2.7 up there. Don't worry about it. So the committee members themselves move it through this process, and the ones doing that are called champions. And during stages 1 and 2, they write their own spec text. This distributes that editorial work significantly. So this is how we're able to sustain our progress. So as we transitioned away from centralized editing, we also transitioned away from emailing around a Microsoft Word document. but there actually weren't too many options for what spec medium to use. There's really only these 5 that we identified. There's plain text, that's like what's used by IETF or their RFCs. There's what we were doing with a rich text document. There's like desktop publishing software that we could use to really carefully lay out something like an ebook. And of course, you can use like LaTeX or FrameMaker for generating PDFs. But we went with web technology. We think that web technology is clearly superior to these. So web technologies are all free and open technologies, meaning like there's already extensive developer tooling available and libraries. The proposal authors already likely have experience with these web technologies. And everybody already has a web browser, so there's nothing to install, there's no software to go pay for. And all the web technologies are based on text formats, so that's really good for collaboration. Again, the main goal of this is like being able to collaborate among members of the committee, and we can use like line-based version control systems to version control it, like just things that we're familiar with, using Git. And of course, the web is an incredibly powerful platform. It has like all kinds of advanced interactivity that we can add. I'll show you some examples of that in a little bit, which should again further justify it. And it also has like end user extensibility through browser extensions, which Geog showed with ES Meta using that. It's also very important for us as a web spec to be able to integrate with other web specs. There's lots of interdependencies between web specs, so we need to be able to like deep link into specific terms or specific abstract operations. So it's really good for all those reasons. So since 2015, this is what our specification looks like. It's a web application. I want to show you some of the interactivity. So like really simply, you can do things just like hovering over some defined term and clicking the references, and you get all the references to that term throughout the document. And you can do this not just for terms, you can do it for clauses, abstract operations themselves, non-terminals of the grammar, tables. So we use that kind of stuff all the time. When reading algorithms, it's really nice to be able to just like click on aliases to see all the instances of an alias throughout the algorithm. And when you do that multiple times, you can get multiple different colors, and that helps you follow things and kind of like track liveness of aliases through each algorithm. We also have this very useful feature to toggle on these annotations for where arbitrary user code can run. This is very helpful for implementers. It was requested and implemented by implementers, actually. So when it can show you places where you need to recheck your assumptions. If like arbitrary user code has run, your assumptions may no longer hold across that step. When reading the specification, we noticed that we jump around a lot between different abstract operations. A simple feature we have is pinning, so we can easily jump back and forth between different sections. There's keyboard shortcuts for it and stuff. And as an example of like some of the like really more powerful features of the web, we implement custom control over what goes on the clipboard. So some implementers like to like literally copy and paste the algorithm directly into their source code, and we can copy text that will be more appropriate for a text-based medium. So like these are, again, this is a small thing, but this is an example of what I mean when I say that the web is a really powerful platform. If there's something you want to do, you basically can do it, and we're not reliant on some proprietary technology or anything like that. So I want to cover the tools that we use to actually create all of this. The main high-level spec generation tool is called ECMARKUP. This is a tool that is maintained by the editor group. So if you see on the right, we have the document source. It is an HTML document with some custom EMU-whatever tags. And on the left, you see that same section as it's rendered in the browser. ECMARKUP uses a library called JSDOM to work with the document as if it was a live web page, which means that it's defined using like a lot of like really high-level transforms. It's kind of easy to read and easy to work with. So like some of its responsibilities are generating the table of contents, finding all those those links and references and like finding all the terms and linking the references like we showed earlier. It enforces a ton of our editorial conventions, consistency in phrasing, our formatting conventions, that kind of stuff, which hopefully is helping tools like we saw with ESMeta, with how it's consuming things programmatically. Checks that aliases are declared and used appropriately. It embeds all the sub-resources like fonts and images and styles into the document. Does all the like clause numbering and step numbering and make sure all those references have appropriate numbers. And does some limited form of type checking, not to the extent that ESMeta does, but it does simple things like checking that exceptions are handled where they're supposed to be handled, that like abstract operations are invoked with the correct number of parameters, that when you like return constants, that's the kind of thing that was expected to be returned from that abstract operation, that kind of stuff, but not like tracking aliases across steps or doing like the refinement stuff that's being done by ESMeta. It also processes this DSL in the headers for defining the like type signature and stuff like that, and that's where it gets that information to do that type checking. Egg markup relies on a library called egg markdown. There's a lot of these. The egg markdown processes algorithm steps themselves. So it uses this like markdown-like notation to annotate the different components of a step. So like aliases are surrounded by underscores. The grammar non-terminals are surrounded by like vertical bars, that kind of stuff. Gram markdown is a similar tool, but this does like annotation for the grammar description. So you can see that this abstract operation is defined piecewise over two different grammar productions, and each of those grammar productions is listed there, and gram markdown is the one that is processing those. So yeah, I was going to do like a whole thing on ESMeta, but I think it'd be a little bit redundant after the last talk. But I'll quickly go over it. ESMeta is maintained by the Programming Language Research Group at KAIST, and GIOC. No, not at KAIST anymore. Generates this mechanized specification, and then from that generates all kinds of tools. The way that we use ESMeta as editors is that we type check the spec using the type checker in CI. So ESMeta does have some parts that it doesn't cover. I think like the module system and like atomics are some of the things it doesn't cover. But that's okay. It doesn't have to handle everything to be useful. And we also, during the integration, we made sure that it has a way to add exceptions for things, for areas that it would report a false error. So we have that ability there, and that means that even as we kind of change the way that we specify JavaScript, if we do it in a way that is incompatible with ESMeta, we don't have to be blocked on each other. We can continue our work, add the exceptions, and later when ESMeta updates to support whatever weird thing we're doing, we can remove that exception. So it's a really good process for us. We find it extremely helpful, and now they can't report any more bugs found by ESMeta because they're found before the PR even lands. So they won't even know anymore. We also use AceBell in a kind of novel way that I wanted to show off. So we use AceBell to check for like newly introduced spelling errors, but we can't just like use a standard dictionary as like you're probably familiar with using it on your own things, because we use like a lot of terms of art, right? And we also don't want to maintain a dictionary of our own terms of art. So what we do is we derive a dictionary from the like target branch by taking all of the existing terms and even like aliases and like splitting up camel case and Pascal case and then using that as a base dictionary, and then we just find newly introduced spelling errors. So you can see like an example of it, just like enumerating all the things that it found that it thinks that it would have thought are spelling errors, and it makes an exception for those. So we also do have to, like I've been talking up all of the web technologies we use, you know, and we're very proud of our specification being a web application, but we do actually have to generate a PDF. ECMA requires that we release a yearly PDF. The ECMA will actually print and ship you a book if you request it. So I have one from years ago, just for the novelty of it. I've never looked at it, but it's fun to have on the shelf. But PDFs have requirements that web pages don't, right? They have page numbers in the table of contents. If you split a table across pages, you have to like repeat headers and repeat captions and stuff like that. The pages don't exist on the web, so there's a whole bunch of things that you have to consider, and there's actually like so many things. So many things. It's really hard work, but there is good news that there is a web standard for this for paginated media. And it can be used to generate like really high quality PDFs. The bad news is that no browser supports this standard. I don't know how you can call it a standard. This is the thing W3C does. W3C publishes these aspirational standards with no implementations. Fortunately, there is a proprietary product called Prince that has implemented it since, and still no browsers support it. But we only generate PDF once a year. So we don't need everybody to be able to generate a PDF. So for now, we can use this commercial implementation. But it would be nice if we could just do it more than once a year, and anybody could do it without running this very expensive piece of software. So yeah, I wanted to go over some additional that's what we are doing. But I see like there's a long road ahead of us for like things we could do, and I just wanted to I think take this opportunity, given the audience, to go over some of those ideas I have. So this is what a proposal document looks like today. It just copies out snippets of the spec, and it adds these like insert and delete tags around certain spans to like say this is the change I want to make. It's not great doing that. It also, there's limited tooling support. Wherever there is tooling support, it's been like manually added, and that is unfortunate to maintain. There's also no way to just see the final state. I want to see what the document looks like with this all integrated and all the changes having been made. When you click on links, the links do work properly. They'll go to the full spec document, but then you're in the spec document, and it's hard to know when you navigate back to this abstract operation whether you're looking at the changed one or not. You can forget the proposal changed that thing. So jumping between those documents is also really annoying to have to do, and you have to manually keep track of the numbering, the step numbering. So if we change the specification, since your proposal was made, you have to realign those numbers. This is a really bad process. Don't get me wrong, it works, and we're able to get a lot done, but I think it could be a lot better. So I've for a long time now wanted, this is 2017, this post, I wanted some sort of semantic diff calculus where the spec authors can write their proposal in terms of these semantic change operations, and then all the tooling can just support those changes. So it wouldn't be just text replacements, it'd be these limited set of semantic changes you can make. There is a tool from a Mozilla engineer that goes kind of halfway here. If you have created a pull request against the spec, it can kind of create something that looks like that proposal document that we saw before. But keeping a pull request up to date is more challenging than being able to, because as it changes, you have to keep. It's very much like making these line-based changes rather than these semantic changes. But it does get many of the same benefits I'm looking for. But I think it'd be great for somebody to explore that. Mika, who is here in attendance actually, from Bergen, is working on this collaborative language design workbench. It's different than a typical language workbench in that It also wants to like incorporate all the social aspects and like the process aspects of language design into it. I think this is like really cool. The goal of this is to like better evaluate the effects of the proposals on the language, because the committee has like a really hard time doing that sometimes. As an example, one of the committee members, a proposal author for the record and tuple proposal, made this tool that helps you evaluate the consequences of all these decision points for the record and tuple proposal. So you can go through and select what you think like an appropriate decision for like the semantics of this expression should be, and then it tells you why that's a bad idea. Right? Because like, and for this proposal, there's no right option, right? Like every single thing you choose, it's like this is a bad idea because of this, right? Every single thing. That's the constraints we have to work with sometimes. But like that kind of thing is very helpful for the committee to try to make decisions. Otherwise, we just keep going back and forth and around and around in circles because everybody always has a rebuttal for every single possible thing we can do, right? And so yes, they're all bad. We need to choose one. Or none, right? As we've done with this proposal is now pretty much not moving forward. I mean, that's you didn't hear it from me. So another thing I want to explore more is this is a tool that another proposal author or just committee member Nicolo made. This when you encode in a like module graph into this tool, it shows you what the internal states of the various like spec internals would look like, and this would be really helpful, I think, for implementers to just be able to use like embedded within the document. I'd love to see all kinds of these like interactive tools within the spec document, so that you don't have to just like run through it in your head or on like a piece of paper, or using your implementation. You can actually have these tools which have been like possibly auto-derived from the specification, and they would be able to guide you in your implementation and guide you in creating test cases and all those kinds of things. We also have we maintain this whole list of editorial conventions. I think there's probably something we could do to express them like more formally somehow. We just this is just like notes to ourselves, but I think that there's probably something we can do. If we express them more formally, we can probably then enforce them automatically better. Because right now, as I said before, EC markup has like some enforcement of some of these, but it's like a bunch of regexes that it runs on stuff, and that's not great. And I would love to see what somebody could do with editorial conventions and that space. If this kind of stuff interests you, there is a group like a subgroup of the committee that meets regularly. I think monthly. You can talk to me or Mikhail. It's free for anybody to participate. You can just we can talk about these things more often. And that's it. Thanks for listening. Oh yeah, questions. I'm happy to take questions if we have time.
Thanks for a good talk. So you mentioned about the annotation about the user code UC tag in the specification. So is it manually maintained or they automatically infer some?
Partially. There are like manually maintained, like manual annotations in the spec, but then there's also like automatic propagation.
Propagation.
Yes.
So at the first you annotate some point, then it automatically propagates that you see text into another part.
Because there's only a couple of like places where it actually bottoms out where the actual user code happens, but we want like any places where that propagates to be to receive those annotations. Yeah.
Okay. Thank you.
I have one question. So about the language maintenance, it seems like a very hard and labor-intensive work, even with all the tooling support. But it's at the same time, it's hard to estimate how much work do we need to keep up the language standards. So I'm curious, how many kind of feature proposals are there, and how many do survive until, say, stage 2.7?
So that's a really good question. Yeah, so a lot of that, it is a lot of work to maintain the language and maintain these proposals. That is why we distributed this work to the champions, right? We want everyone to write their own spec text. Mika actually has some research recently on tracking proposals, active proposals, and how far they advance, and like relationships between that and the like category of proposal it is. I off the top of my head, I don't know. There is a if you go to github.com/tc39/proposals, there's a list of all the active proposals. Some of them will not be so active, but it'll give you an idea of roughly how many in each stage. It's broken down by stage, on the order of 100 to 200, I guess. That's about how many. Yep. Comment?
How often do you manage to successfully have conversations within companies about putting engineer time towards these tools versus kind of hoping volunteers show up and then enough volunteers show up that it kind of keeps going?
It's almost all volunteer, passion driven. Very rarely are like the tools like I showed supported by like company time. A lot of the participation within committee is supported by company time, and the work on the proposals. So when those tools are directly related to proposals, like an individual proposal, that ends up, so like Ashley's tool for deciding record and tuple, for like evaluating the consequences of record and tuple decision points, that was almost certainly sponsored by his work because it's directly related to his proposal. But for things like Nico's tool that would be like integrated into the spec document, no, we don't really see any. Like I hardly can get time to work on EC markup to improve the spec.
Yeah, this has been my experience engaging with people in the WebAssembly standards body as well. But I was just impressed by so many tools you had, so I wondered if you had a better story than us.
Just more passion.
We'll talk in the break.
And what's going on with F5? Because there's the JavaScript standardization story inside F5, but there's also the WebAssembly story inside F5. So is F5 actually sort of really quite supportive in your endeavor to do this, or there just happens to be a bunch of enthusiasts that randomly have ended up there?
Both, there's a bunch of passionate people for both JavaScript and for WebAssembly within F5. F5 is very supportive of me contributing my time to both the JavaScript standardization and WebAssembly standardization. So I participate in both. I'm only editor for TC39 for JavaScript, but we are very committed to advancing the standards, and not just for our own interests. We also feel that just doing things that generally benefit the community also help us in that it reflects our image there. So we're not very selfish in our contributions. A lot of the proposals I've been working on have not had an immediate need within the company internally. We just know that they're some of the most demanded ones from the community, and that would be a great way for us to contribute.
So I had a related question. Like, you've been one of the spec editors for like 5 years. So how's it? And how long do you think you're going to work on that? And what do you want? You already mentioned that, but what do you want from the academia or all these people working on the spec and mechanization?
Thank you for that question. So I originally, as most people do, I guess, I wanted to become editor because I was frustrated with the state of things, and I said, I can do this better, right? I think things are really good now, so I don't think I need to be editor for much longer. I would love to do a whole presentation on like some of our editorial accomplishments. That's actually one of the original things I wanted this talk to be about, because I think they're pretty good improvements, and I'd love to explain why. But I feel really happy with the editorial accomplishments we've had as this group in those 5 years, and we've also done that like documentation of our editorial conventions. So I feel good that whoever we passed it off to would understand like why things are the way they are and how to continue making them, continue being consistent to those values. So at any time, I may no longer be editor. It would be great to get that amount of time back. As far as like what I would want from this community, I mean, I don't think I need to request. Like the Yes Meta stuff came to us, and I'm super happy that that's happening. So continue with these like great ideas for like tools, and I am happy to be your advocate within and be this liaison. Just like reach out.
So thank you for the great talk, and let's give him a big hand. And we'll be resuming our session at 2:05 after lunch. Have a nice lunch.
Can you just